All right, let's get started. Morning, Toldfish. Morning, Latitude. We'll just wait for Rin. All right, so welcome back, I guess, to regular scheduled lectures. Last week we did a bunch of demos and stuff, but we had no lecture questions, so we're back to regular lectures, whatever that means. All right, so homework 4 is out. Introduced this briefly on Friday, so I won't dwell on it too much right here. But what we want to talk about for this homework is authentication. This is the big one. Authentication, a registration, and a login form that'll issue an authentication token. So whenever somebody visits your site, they'll be authenticated. They'll be logged in as that user. And then we'll add that to a chat feature. However you want your chat to work. I'm not going to, we saw several ways of doing chat by now. However you want to get your chat app working, AJAX calls, HTML forms, WebSockets, whatever. As long as users are authenticated so that whenever somebody sends a message to the chat after logging in, they actually have their username associated with messages that they submitted, just like what you would expect from a chat app. That's what we expect from them. Cross-site request forgery tokens, we did these in homework 2 as objective 5. But it wasn't super meaningful in Objective 5 because we didn't have authentication yet. We didn't have any way of associating a token with a specific user, which I realize there is a way to do it. I might change that next semester, but anyway. But we're going to associate these tokens with a specific user, so we prevent the attack where the attacker is going to send a request to our site, get a valid token, and then send that token with AJAX requests through their JavaScript. We're not going to allow that attack anymore because these tokens are going to be associated with a specific user. This token was issued to this user, so I need to see that, bless you, I need to see that token associated with that specific user, request from that user. And then HTTPS. This one this is very much like the last homework where we have, or the current homework, I suppose, where we have WebSockets is the main bulk of the assignment. The first 4 objectives were WebSockets. For this, the first 4 objectives are authentication. And then objective 5 is I don't want to say an application. WebRTC was more of an application. We have WebSockets set up. We can use that to enable WebRTC. This is more of, I don't know what I want to say. To make authentication meaningful, we do need HTTPS. So it's kind of, I guess, a little bit of the inverse there. Anyway, it's an extra topic that is a little related, but a little unrelated to the main topic. And I don't want it worth too many points. So it's going to be its own thing, because it's very different feeling when you're doing your homework than this one. I don't really know how to set that up without just going through the whole several weeks of content for that. You'll find out all about that starting next week. So today, we just want to talk about cookies. To get authentication, we need that authentication token, which is going to be set as a cookie. So we have to learn how cookies work first. So objective 1 is just your ease into this, learn how cookies work, set a cookie, read a cookie. It's going to be a visit counter. So you can display how many times a specific user has visited your page by reading the cookie that you set for that user. So that's what we want to get today. So to that end, let's talk about cookies. Yeah. And when I'm opening buffalo.edu, I have to be careful to not show my cookies, just in case somebody wants to watch the video, copy them down, and log in as me. All right, so let's talk about cookies. So HTTP is stateless. We say this fairly often. You've probably heard this before. Even in 199, if you took 199, Alan's module about web development, he told you this as well. I'm telling you it now. But that might not mean too much to you quite yet. So let me just elaborate a little bit on what we mean by HTTP is stateless. What we mean by that is that when your server is handling an HTTP request, the only information you're using is that HTTP request. You take that HTTP request and you handle that request in isolation. So when say somebody requests your HTML, You serve the HTML, and then you completely forget about that user and that connection, that TCP connection. You forget about everything. And then that same user sends a request for your CSS. From your server's perspective, that may or may not be the same user. Doesn't matter. It's two completely isolated HTTP requests. Our server does not care that those were made by the same person. Nowhere in your server code did you say, okay, you requested my HTML. I'm expecting you to request my CSS. I'm expecting you to request my JavaScript. You're probably going to want this Flamingo. We don't code our web servers that way because that's not how HTTP works. HTTP, to serve that sample site, is 4 separate isolated HTTP requests with no state being set between them, no memory of the prior request, no memory of, okay, this is one specific user making 4 requests. Server doesn't care. The server could get 100 requests just for the Flamingo image and no requests for the HTML. Your server's going to handle that just fine because it's stateless. That's what we mean by stateless. We're taking the request, handling that request in total isolation, and doing whatever we do with that request without thinking about any other requests. So how do we get state in a stateless protocol? Of course, the answer is going to be cookies. That much you did see here in 199 if you took that module. The answer is going to be cookies. But we want some form of state in our connections. The main application is user authentication, or at least the main one we as users care about, on the user side we care about, is authentication. I want to log into a site, and then I want that state to persist, that fact that I logged in, that I have a session, that I'm interacting with this site multiple times as me, as like one session. That's something I want. When I log into a site, I don't want to have to send my username and password every time, which if we're fully embracing statelessness, we would have to send our username and password every single time we do anything at all on a website, anything that requires authentication anyway, because if the server can't say, okay, this request was made by the same person who made this request, if we can't say that, and I'm posting 2 messages to a social media site, well, it's going to want my password both times, so it can authenticate me. It needs to verify that I am me. So, as we all know, that's not how it works. We log in once, and then we send multiple requests, and we're authenticated all the time until we log out or until the site kicks us off and says, you have to authenticate again, like UB does every 7 days. That's how the internet works. So we want to talk about how we get that. We're not going to talk about authentication today, but we are going to talk about the mechanism cookies of how to do that. So the idea, the quick overview of it, is you log in, and a random authentication token is set as a cookie, and then all subsequent requests, your server is going to check that cookie, check that token, see who the server issued that token to, and then verify, okay, you must be logged in as this person because you have the token that I gave to that person. And these tokens are really long and random strings. Nobody could possibly just guess it by brute force. So you must actually be this person. So that's the functionality we want. So we're using more than just HTTP. We're getting the HTTP request. That request is coming with a cookie. We take that cookie and then go to our database, which will have state. Our server can have state. We go to that server, check the state in the database, which is going to be this cookie, this auth token was issued to this particular user, and then handle the request that way. We're going to verify that they are authenticated that way. We'll talk more about authentication tokens specifically on Friday, and we'll talk about authentication itself, username and password, and mostly storing passwords securely on Wednesday. But today we just want to talk about how cookies work. So I think I got ahead of my slide here. So we're going to set the cookie, and that's how we're going to remember information. That's how we get user sessions in a stateless protocol is cookies. Cookies is the answer to everything. It's a very, very old protocol, very old mechanism, and it's still going strong today. Cookies, it looks like these aren't really being replaced. If cookies are being replaced, they're replaced by something that function the same way. Wait, does that ever even happen? I mean, you could. It doesn't matter. Cookies are pretty much here to stay. They're withstanding the test of time. So cookies work through HTTP headers. This is how they work. So whenever you want, since they're in headers, ASCII only on cookies. Cookies can only have ASCII characters. It's just the way it is. Only ASCII characters in cookies. If we want any non-ASCII characters in a cookie, we're going to base 64 encode them. So if we base 64 encode our non-ASCII text or our binary information, any arbitrary bytes, we're going to base 64 encode it and then set the cookie as that base 64 encoding. Just like we did with the accept in WebSockets, or that you're currently doing. Hopefully you're not still working on Objective 1 of the homework. You're pretty far behind if you're working on Objective 1 of Homework 3. But for that accept header, we're computing some binary, just some random bytes, some arbitrary hex. That's going to be the hash digest. And we want to set that as a header. Headers are ASCII only, so we have to base 64 encode it, which takes any arbitrary bytes and encodes it using only ASCII characters. So that's why we have to have the base 64 encoding on that accept for the WebSocket handshake, because headers are ASCII only. Same is true with cookies. We're not going to do any non-ASCII cookies in, well, it depends on how you're generating your tokens, I suppose. I can't really say that. But ASCII only in your headers. And these are the two headers. There's only two headers that we have to worry about when it comes to cookies: set cookie and cookie. That's it. So let's talk about these two headers and how to use them. Did I hear rave? Cookie Monster. All right, so set cookie. This has got to be like the complete opposite of a rave. I'm sorry. I can't. I got to talk about cookies, HTTP headers. I don't know how to make this more entertaining, but set cookie and cookie. So set cookie is going to be our way to say set a cookie. And cookie is going to be where all the cookies are stored. So let's talk about these in more detail than that. So set cookie, this is our way of telling the client, hey, you should set these cookies, or this cookie, rather, to this value. So set cookie, the syntax is going to be key equals value. The set cookie header has the value with a key and a value, or a name and a value. So if I set this header on an HTTP response, so the client said, hey, can you give me some information? And I say, okay, here's your information. By the way, in the headers of that response, I'm going to say, by the way, can you set this cookie to this value? So if I set a cookie ID to some random string, or I have a set cookie header that sets the visits like you have to do for Objective 1, hey, by the way, set this cookie to this value. Then the browser is going to set that cookie to that value, store it locally on that user's machine, and then every request that comes after that, they're going to set those cookies in the cookie header of those requests. Those cookies that you set, that you told the browser to set, are going to appear in that cookie header. So that's the overview of how they're going to work. If you've messed with cookies at all before, including in 199, you set cookies client-side. The client can also set their own cookies. They can change their cookies. They can do whatever they want. They're their cookies. They can do what they want with them. So our browser saying, hey, set this cookie, it's more like a suggestion. Most clients are going to respect that. The browsers are going to respect that. And our front-end code is going to respect that. But the users can mess with that. So that's what we did before. We would go into like the JavaScript. And I guess it was still coming from the server in that example. You would request the JavaScript from the server, and then in the JavaScript that the server sent, you're setting a cookie in that JavaScript. You can do it that way too. It's more risky that way because you're letting the client handle their own cookie setting. So there's no guarantee that that cookie will be set. In fact, when you're using set cookie, there's still no guarantee that that cookie is going to be set. For our purposes, like for the homework, when we're in control of the front end and back end and we're the ones testing, that cookie's going to be set most of the time, except in the testing procedures where we manually delete the cookie. Of course, it's not going to be set. If you need to send multiple cookies on a single request, what you'll end up doing in your homework, when somebody logs in, you want to, actually, no, you wouldn't, sorry. You don't have to set it up that way. I was going to say when someone logs in, you're incrementing their visits and setting the auth token, but you wouldn't be doing that at the same response. But if you do want to set multiple cookies, you can use multiple headers for that. The set cookie header can only set exactly one cookie. You can't set multiple cookies with this header, but you can duplicate the header multiple times. This is something that's allowed. It doesn't come up in this course, at least until now, but you can set multiple headers with the same name, and those are treated as multiple headers. This isn't a true key value store, so like the parsing that I recommend and that I do in my solutions even, where you parse all the headers into a key value store, technically that wouldn't handle multiple headers of the same name, but it really doesn't come up for the client requests. But for responses, for setting cookies, this is one instance where we do want to take advantage of that feature and say, look, I want to set multiple cookies. Here's multiple set cookie headers. Perfectly valid and used quite often. A lot of sites set multiple cookies on a single response. So that is allowed. And we can take advantage of that to set multiple cookies, if that's something you choose to do. The cookie header in our request, so once we set a cookie, the browser is going to send all the cookies on every subsequent request that they send. They're sending them all in the cookie header, and the cookie header can have multiple values. It will contain every cookie. So this can have multiple cookies. Luckily, our parsing code still works for headers. If you throw them all in a good big key value store, everything still works. Let's play cookie clicker. I'll break cookie clicker again if somebody wants to see that. I don't like doing it too much because I used to do it in 199. You probably, most of you or all of you saw me do that in 199. I'm not going to keep breaking it and keep showing you the same demo unless you want to. I'll show it. I'm happy to show it. I think it's fun. What's the difference between local storage and cookies? Oh, good question. I do want to talk about this. Local storage. So local storage I won't talk about in this class, I guess, except right now or on demand. But I don't have any content explicitly talking about local storage. Maybe I should. It's more of a front-end thing, but it's ubiquitous enough that maybe I should talk about it. The CSE312.com, for what it's worth, uses local storage to remember which sections are collapsed and expanded. And I believe for dark mode as well, to remember that you're in dark mode. So local storage is, as the name implies, it's just stored locally on the browser, but so are cookies, so what's the difference? Local storage is not sent on every single request, is the difference. So all of your local storage is never sent, none of your local storage is ever sent to the server automatically. So if you have local storage that you want to send to the server, you would have to read that local storage in your JavaScript, attach it to a request, and an AJAX request, and then send it over to the browser, or to the server. So it's just a way to store things locally. Cookies are a way to store things locally that are also sent on every single request to that server. So there are different uses. Usually, local storage is used when the server doesn't need to know that information. My server for CSE312.com doesn't care what sections you have collapsed or expanded. I just don't need that information. That's a you thing, so you store that locally. And in dark mode, I don't need to know that either. You store that locally, and then I have JavaScript, which is going to read your local storage and then modify the website as needed, collapse and expand sections, set the CSS for the site. It's going to do all that locally. Cookies are when the server needs to be in the loop. The server needs to know your auth tokens. The server doesn't really need to know the visits. You could do this strictly client-side with local storage. That would work as well. But for our purposes, for what we're doing here, which is teaching you how to use cookies, the visit counter is going to go to the server. The server is going to generate the HTML and then send the response with that set. And local storage is all front-end JavaScript. It's actually pretty easy to use. You do local storage.set, local storage.get. Just works like a key value store. All requests contain cookies? Kind of. Not if no cookies are set, but every request is going to contain every cookie that's set, with a few exceptions that we'll get to in the later slides. There are some cases where certain cookies will not be sent on certain requests. But not every request contains cookies. Like all of your testing so far for homeworks 1 through 3 didn't contain any cookies unless sometimes the IDE will set some cookies, or whatever you're using to test your server is going to use some cookies. Sometimes that can happen, or your browser just sets some cookies, or you were developing another site on localhost and you have cookies set on localhost. There are a lot of reasons why you might have cookies testing homeworks 1 through 3, but you didn't necessarily have any cookies for homeworks 1 through 3. So all those requests didn't contain cookies unless you had them set from something else. Bless you. Yeah, if there are cookies, they're sent. So websites that don't use username logins, they actually use cookies for a better experience. What are they using it for? If they don't use, oh my goodness, cookies are used for everything. I'll do some demos after I'm done with the slides, but cookies are used for so much stuff. The biggest one is tracking. You wonder how you go to a site over here, and somewhere over here, this different site knows what ads to show you. It's because they have tracking cookies all over the friggin' place. That's mostly what they're using. So better user experience means we can show you targeted ads. I know some people consider that a better user experience, so they're allowed to get away with that wording, but that's about what they're using it for. Auth and tracking you, which even auth is tracking you. If you're logged in, obviously you're being tracked. So better user experience is usually targeted ads, unfortunately. Yeah, Nicholas has got a tracking you. Yeah, people using maps. But luckily set cookie, that's the browser's problem. So they have to code that multiple set cookie header stuff. We ain't got to worry about that. How does the server know not to resend the set cookie header? Let's say the server does that on the home page. They're going to read the cookies. So they read the cookies and see which ones are missing. If there's one missing that they need, they're going to send the set cookie response, the set cookie header. And you'll see that in Objective 1. So you need the visit counter cookie. You're going to read the cookie to see what the current value is, and then set the cookie to that value plus 1. Or if the cookie doesn't exist at all, you're going to set the cookie to just 1, exactly 1. Yeah, the server knows nothing. It's up to you, the developer. Yeah, exactly. Why are cookies called cookies? You know, I was actually wondering that this morning. I'm like, I looked it up before, and it's some silly reason. But I completely forgot, and I didn't look it up. All right. I like all the questions. I like it. So let's talk about directives. So we can set cookies. Those cookies are going to come back to us. But there are certain directives that we can use to specify exactly, I shouldn't say exactly, but more information about this cookie. And some of these directives are semi-required, I guess. We'll talk about it. So you can have multiple directives. This uses the same syntax we've seen before, like when we're setting charset UTF-8 on our content type. It's multiple things are separated by semicolons, and some of the directives are key value stores. Some of them are just simple strings. Let's talk about it. So first directive expires. If you had JavaScript, at least the way Alan does it in 199, you've seen this one client side. You have to set the expiration time, the exact time of the expiration of that cookie. After that moment in time, I guess, it's a full second. So after this second in time, that cookie is not going to be sent to the server anymore. It expires. The browser's going to delete it if it's doing its job. That cookie's expired. So expires equals, and then the exact time down to the second in this exact format, which I find pretty cumbersome. This, I believe it's ISO format. I don't remember. But it's in a specific format. It has to be in this format, or else it doesn't work. For the rest of us who value our sanity at least a little bit, max age is a bit easier to work with. Max age is a number of seconds, and then the cookie should expire after that many seconds. So if you want a cookie that expires 1 hour after it's set, max age 3600, that's going to get you there. Much cleaner. You don't have to remember that long format, which you'd have to, at least I have to look up every time. Max age just says, let this cookie last this long. Max age or expires, one of the two, are semi-required. This is the one that's kind of required-ish. If you don't use either of these, the default expiration for a cookie is at the end of that session, which is when the browser is closed. Mind you, not the tab, but the entire browser, not even browser window, but the entire browser. You close the browser, and that's going to reset all of your session cookies. They're all going to go away. But as long as that session is open, as long as you don't close your browser, those cookies are still going to be set, those session cookies. If you set expires or max age, you can close and open your browser as many times as you want. That cookie's still going to exist until it hits its expiration time. So we don't want session cookies. In the testing procedures, we're actually going to close the browser and open the browser back up. Not the tab, the actual whole browser, and make sure that cookie is still set. Yeah, the day name and the exact date. I know, it's so cumbersome, that date format. And usually not what we want. Like, why not just use max age? I don't know of a scenario where I want all my cookies to expire at a very specific time that's not relative to the time that the cookie's set. Unless I'm trying to set it to like basically forever, like the year 2050 or the year 3000 or something, and I don't feel like having some giant number in my max age that's a little unreadable. That's the only reason I could really think of. If I want a token that effectively doesn't expire, I would use expires. Then it's very clear to anybody reading my code and looking at the cookies, like, this expires in the year 3000? Yeah, that's just an infinite cookie. It doesn't expire. The expiration is 80 million. I don't even, that's probably not even long enough, but that's a bit harder to understand what I'm saying. Max age, if I'm setting that to some amount of seconds, you got to do some math to figure out, okay, is this lasting forever or is this just a year? I don't remember. So there are a few situations, but not much. All right, let's talk about a few more directives. Secure. You just slap this directive on your cookies and it makes them secure, right? No, false. Which is a little misleading, I think. You slap a secure directive on something, it kind of puts off that image, like, oh, you put the word secure on your cookies, they're secure now, don't worry about it. They're fine. People can absolutely steal a secure cookie. They can hijack these cookies. So don't think that just because you put the word secure that you actually have security. But what secure means is that it's only going to be sent over HTTPS and not HTTP. So whenever there's an HTTP request, whenever the browser's making an HTTP request or the user typed in HTTP in the URL bar, these secure cookies are not going to be sent. These are typically our auth tokens are going to be set as secure, not for the homework because HTTPS doesn't come until Objective 5. If you want to add secure to your cookies, your auth tokens after that, be my guest, but it's not something we're checking in the testing procedures, just in case somebody didn't get to Objective 5. We don't want to take away points for that. So they're only going to be sent over encrypted connections, which means these cookies are always going to be encrypted for what it's worth. So these cookies, if you don't want your cookie floating around in the air unencrypted, where anybody can just read those cookies, slap the secure directive. It does improve security to some sense, but it doesn't make you absolutely secure for what it's worth. But these will only be sent, if you use the secure directive, over encrypted connections. So don't set this. If you're not doing HTTPS, don't set the secure directive because you're never going to see your cookies on the server. You'll never see it. because it's all HTTP, until you get to Objective 5 and you get your HTTPS finally. HTTP only. This one is more useful for our homeworks. HTTP only means you can't read these cookies in JavaScript. So if you go to your JavaScript console and you type document.cookie, it's going to print out all of your cookies that are set, except the ones that are set with the HTTP only directive. This is very useful to prevent hijacking because you can still mess with these cookies. By the way, you open up your browser console, you go to your cookies, you can still see them, change them, delete them, whatever you want to do. They're your cookies, you can do what you want with them. Even with the HTTP only or secure or whatever directives. But what this does is if somebody's able to inject some JavaScript into your client, either you're vulnerable to HTML injections, which you better not be in anything going to production, but if you're vulnerable to that and somebody's able to inject some JavaScript or some other way somebody's able to get some JavaScript running on your client's machines, maybe they have some browser extension that they're like, oh, this browser extension will improve your life, and somebody downloads it, but it's actually attack code. It's just running JavaScript that attacks things. And it says document.cookies and sends all those cookies to their server, and their server stores them in a database so they can attack you at their leisure. HTTP only cookies, they're not going to be able to get them. So anybody who injects JavaScript can't steal these cookies. Significantly reduces the ability for anyone to hijack your user's cookies. So that's one we really like. Path, I don't really use this one. I don't find it that useful, but just to be comprehensive, I'm covering all the directives. Path, these cookies are only going to be set on requests that begin with this path. So if you want cookies set to just a subset of the requests, you can use path. I find this kind of useless. Like, just send the cookies all the time. You really have to be worried about performance if you're trying to cut down your cookie payload for certain requests. But at some point in your careers, you might be at that point where you want to get that optimization. Path is there for you. I don't even want to say that, but like, don't use this for security. Like, if you're not trusting other parts of your own server, you got bigger problems. So it's not really useful for security, but it can reduce the payload. And then same site. So same site, there are 3 different options for this, and this controls when third-party cookies are sent. So we have 3 options. Strict, which means this cookie is only going to be sent to your server. So if you set a cookie from your server, only requests going to your server, or rather your domain name, that's how the browser is going to determine, only requests sent to your domain name are going to have that cookie attached to it. Or from your domain name, I should say. Only from your domain name. And only being sent to, I feel like I said that really weird. Only requests from your domain to your domain. That's the only time your cookies are sent, if they're strict. None means those cookies are always sent all the time. So if somebody, any other site, anybody on the planet writes and hosts, and they decide to add an AJAX request to your site, those cookies are going to be attached to that AJAX request, which might not be something that you really want. The default, if you don't use either strict or none, or you explicitly set it to lax, this is the default option, and this is only going to send the cookies when somebody's navigating to your page. So somebody has a link to your page, they click on that link to make a request to your home page. That request is going to have your cookies, and all of the first-party requests are going to have your cookies still. You'll still get all the strict functionality, but you also get the cookies when somebody's navigating to your page. If you have none as the directive, the cookies are always sent. The danger with this one is, say you're logged in, you have a client logged into your site. You issue your token, you say you're logged in. If I see this token, I'm respecting that request. somebody has an attack site, they send an email and say, click here for free Bitcoin or whatever. You click that link, that has a site hosted, and as soon as the page loads, it fires off an AJAX request to your site. If you have none set on your auth token cookie, that's going to be viewed as a legitimate request. And maybe that request posts something funny to your social media. Maybe you're writing a banking software, and that request transfers money to the attacker's account. Maybe I don't know, I'm running out of examples, but it can wreck stuff. It can send requests on that user's behalf that are going to be treated as legitimate. So the attacker can write whatever AJAX request they want. They can look at your front end, look at the APIs and how things are, the format of the requests that you expect, and they're going to send legitimate-looking HTTP requests on behalf of any of your users who click that link in that email, that shady link in the email. Somebody clicks it, they can just do whatever. Never use none on your, any cookies. But don't use none on your auth cookies especially. This is very dangerous. That really opens up the door for all kinds of attacks. Lax is usually all right. Strict if you want more security, if you don't want anybody else in there. None is going to be set. There are important cookies to companies out there that will use none, and those are your third-party tracking cookies. When they want to track you, they're going to set all those cookies to none, because they always want those cookies sent. Don't trust your cookies. Which one is safer, HTTP only or secure? Use them both. Don't choose one or the other. For your auth tokens, in the real world, I don't have the requirement for secure on your auth tokens here, but in the real world, you're using HTTP only and secure. Can hackers hijack the browser's cookies in the secure model? Oh, yeah, absolutely. Same site. You do same site as well. You do same site strict, semicolon secure, semicolon HTTP only. In the real world, on your auth tokens, you want everything you can get, all the security you can get. Except for Trevor. Trevor's perfectly secure. And the clients can mess with these cookies. They can change and set these cookies to whatever values they want. They can mess with any cookies. Always verify your cookies server side. Never just trust that you get a cookie, that it's the right value. For Objective 1, it's not that big of a deal. If somebody changes their cookie, their visit counting cookie to 1 million, and your browser is going to respond and say, hey, it's your 1,000,000th visit, good job. That's fine. But your auth tokens, you have to verify them. When you get an auth token, you have to look it up anyway to see who it is, but you can't just trust that. For example, if somebody's getting really lazy, a really lazy dev who says, if a cookie named auth token is set, then you are logged in, so I'll allow you to do actions that don't require me to look up your username. That could be something somebody's tempted to do, and that's bad news. Don't do that. Always verify your cookies. Look up in your database. Make sure it is a valid cookie. It is the value you expect it to be, etc. Because users can change their cookies. So that's my last slide. Let's do the lecture question, and then I want to demo a few things about cookies. And cookies are always vulnerable. If somebody has physical access to your device, they have all of your cookies. There's no protection against that. So at some level, cookies can always be stolen. Even with every directive, every two-factor authentication does take care of that. Maybe I should talk about that in lecture sometime. Wait, does it? I didn't think about that. You might be able to get around 2FA. It's clearly Siri. Yeah, it's one of Siri. This whole lecture was a lie. I'm just doing a late April Fool's joke. All right. Anyone need more time? Great. Okay. Let's take a look at some cookies. So if you go to the Application tab of your browser, you can see all the cookies that are set. Some of these are my auth tokens. So the values, these random looking values, are going to be my auth tokens for some of these. Here's buffalo.edu. If you got my, somewhere in here, my auth token, you're going to be able to access my account. We'll talk about that on Friday. But we can see like HTTP only, secure, same site. We have these directives set. We can have multiple directives set on several of these. Same site. What's this one? Is it not going to expand it? It's not going to show me. Anyway, same party. These kids and their new cookie directives. So we can see if we look on this site, there should be something on here. So I see all these cookies for youtube.com when we go to buffalo.edu. I chose buffalo.edu because I didn't think I'd find tracking cookies, but here we are. So I can see these youtube.com cookies. So if we look through this site, we're probably going to find YouTube somewhere, rearing its head. Here we have some Twitter. I'll show those ones as well. Unless I got something weird going on with my browser. Why? Left side, YouTube right here. So YouTube makes it really easy to embed YouTube videos on your sites out of the goodness of their hearts. Right? No, they're tracking you. They want to track you on wherever you go on the internet. You embed a YouTube link like this, you better believe they're tracking you. They're saying, oh, you watched that video over on buffalo.edu. And they use that information for whatever they want. They can learn, they learn that you're probably a UB student or at least interested in attending the college. They can target you a bit more with that information. We have Twitter. So if we look through our cookies, we have these broken down by site. Well, Twitter's got their tokens right there too. And they're tracking me right there. Same site on these tracking cookies. We're going to expect them to be none because this is sending off requests, AJAX requests to Twitter, and Twitter wants those cookies. Twitter gets this request, hey, give me the information for this Twitter feed. Twitter's going to look at these tokens, say, oh, you're this user. I'm not logged into Twitter, so they don't know who I am, but I got this guest ID, which means they're going to remember who I am anyway for several years until 2023. They're still going to associate any requests that I make with this token. Even though I don't have an account, they're still tracking me. They're still remembering what I do over on buffalo.edu. I'm going to have this same token set. If I go to another site with a Twitter feed on it, I'm going to send this same token, and they're going to see that I'm somebody who goes to buffalo.edu. And then I went to this other site, and this other site with Twitter on it. YouTube's doing the same thing, except I'm logged in there right now. I think I'm logged in right now. So they're actually going to track me specifically instead of some random ID for some random user. But they're tracking me through these cookies. This is how they do their tracking. They don't have HTTP only set, so if I HTTP this, those cookies are still going to be set. Oh my goodness, they finally did their redirects. This is another reason I use buffalo.edu. They weren't redirecting HTTP to HTTPS, but they finally fixed that one, thank goodness. And one thing I'm surprised to see is that Instagram's not tracking us, right? Or am I just forgetting who owns Instagram? I thought Facebook owned Instagram, right? Meta, and I don't see any of their cookies, so for what it's worth, that's FBP? I didn't see it. Buffalo, Twitter, YouTube, Buffalo. This one, it's buffalo.edu. Or do you just want to get my value? What is this? So I'm surprised I'm not seeing some meta tokens in there. Maybe they coded something wrong. I don't know. And if we go do the same thing over in a private tab, they're still going. I didn't even look at what domain this is. Buffalo. So even in a private tab where we're not being tracked, the browser's doing everything it can to not track what's going on, they're still tracking us. They can still see us. Well, Twitter actually isn't. We only have one token, but actually this isn't even a tracking token. I mean, UB's probably not tracking us. But we can see that token. If we delete this, it should come back. I guess not. Well, I don't know what that cookie's doing anyway, so maybe that's why it didn't come back. Okay, there it is. So when we go to our network, let's take a look at the mechanics of this a little bit. Refresh. And on this very first request, we shouldn't see any cookie headers. I don't see any cookies, but on the response, let's see if we can get a set cookie. Looked like it took a refresh, so let's refresh. Or maybe it was on one of the AJAX calls. In that case, we're not going to find it. Yeah, it's probably on one of the AJAX calls. So let's look at the cookie. So that cookie is going to be sent in that header every single time. If we go back to our if we go back over here, if we look at, I have to be careful here because I'm going to give away my tokens. We go to, I don't use cookies. Yes, Twitter, since we already established I'm not logged in. So on the request, these cookies are going to get pretty long. There's going to be every cookie, key value, key value, key value, key value, all separated by colons. So every cookie you get, all of them that are set, are going to be sent like that. And if I go to my console, document.cookie, it's going to print out all of my tokens there. So if you want to access them via JavaScript, document.cookie. But if we look at the actual cookies, some of these are HTTP only. Well, we got to get only the Twitter ones. No, none of the Twitter ones are HTTP only. Well, I can't do that. But the ones that are HTTP only are not going to show up in the console because they're HTTP only. So you can play with that. You can go to sites and take a look at all the cookies, see who's tracking you where, and see what those cookies are. With that, have a great day. See everyone Wednesday.